Hello everyone, so we have another MATHCOUNTS problem. So this was number 30 on the sprint test. So this is actually interesting because I seen same question in a MATHCOUNTS in another like AMC 10 question. So I'll find that and then share in the description. You can take a look at as well. So, but the question says how many ways are there to arrange the digit 1 through 9 in this 3 by 3 grid such that the numbers are increasing from left to right and each row and increasing from top to bottom each column. Okay, so it's obvious that like if you're gonna increase from left to right and then top to bottom, so our smallest number should go here and then largest number should go here. So, but after this, like we have some conditions to think about it. So, like you can just go with some cases. In my like solution, I'll try choosing the middle like number as my case. Okay, so because this is going to determine how we can finish the other one easily. So I'll say this middle number can be less, like cannot be 3, because if I have like 3 right here, so I should have only 2 left. So this should be 2 is one of these, or 2 has to be this one, but there is no way to get 3 for this guy. But if I have 4 here, right, it is possible, because if I have this is 4, I can have 2, 3 here, but it doesn't work that way because this has to be smaller than this, which means 2 has to go here and 3 here, or the other way around. But this might be 5, so this might be 6, so it does work. So which means the smallest number I can choose for this middle square is 4. Okay, so let's go with that case 1. Case 1 is the middle one is 4, okay? Middle square is like 4. Okay, so when this is the case, I mentioned just a few seconds ago, so these two has to be 2 or 3, because this can't be 2 or 3, because if this is 3, then this has to be 2. That means 1, 2, 3. Then this has to be smaller than this, but there is nothing left over, so we cannot choose anything like that. So which is why this has to be 2, this 3, so or the other way around. So I'm gonna go with this is 2 and this is 3, for example. When I have this, there is 2 spot right here and 2 spot right here left, and then the numbers left over so far is like 5, 6, 7, and 8. So we have four digit like left. I need to finish these for those. You can do a really careful casework with this, but I'm not gonna do that, because every time you choose 2 numbers from this list, let's say you choose 5 and 6, 5 has to go here, 6 has to go here, 7 here, and 8 here. So which means whenever you choose 2 numbers, you actually determine all others as well. So if I choose 5 and 7, right, for example, so 5 goes here, 7 goes here, and then the remaining 2 numbers in this gonna be going here. So for this case, then the question is actually asking how many ways can I choose 2 from other 4 numbers, which is gonna be 4 times 3 over 2, which is 6. So, but this is the case when I said this is 2, this is 3, but I can swap these as well. So which is why I should multiply this by 2. So which will give us 12 ways to finish the first case. Okay, the case 2, the middle number is 5. So let's think about the middle number is 5 now. So I'll take this. If this is 5, the things are a bit different, because you may have now like 2, 3, 4. So that's possible, which means we really cannot just say this has to be 2, this has to be 3, or the other way around. So we have like 3 like spot to fill. But let's try see, like if I choose the remaining digits, I have like 2, 3, 4, 6, 7, 8. So like choose anything, like any 3 numbers. Like let's say I'm gonna choose, let's say like 3, 6, and 7. I'm just randomly choosing now. 3, 6, and 7. In this case, if that's the case, since 3 and like 6, 7 chosen, 3 has to go like one of these. Let me double check. So 2, 3. Okay, so 2, like 3, 6, and 7. So this has to be 2. I mean, not 2, that's 3, because that's the smallest number in my selection. And then to satisfy the condition, I'm just trying to finish up these 3. So 6 and 7 has to go this way. So that does work. And the remaining numbers, 2, 4, like 8, has to be 2 here, 4 here, and 8 here. So let me write those. So this is one of the ways. But the thing is now, when you determine these 3, the other 3 actually determine as well. And then you have only one way to finish the entire grid. So the reason I'm saying this, because when you determine any 3 of these numbers, to choose these 3 spots, then you're actually almost done. So which is why this can be done 6 choose 3 ways. But the problem with this, there are some bad cases where I can choose 2, 3, 4. So if I choose 2, 3, 4 as my 3 number selection, so then for this spot, so this has to be 2, this has to be 3, this has to be 4, but it doesn't work because after 5 you have 4. So this is a bad case. So we cannot really have that. Or the same thing with 6, 7, 8. So if I have 6 right here, 7 here, 8 here. So this doesn't work either because I have 1, 6, 7. So the next number I have like 2, right? So 2 or 3 and 4. But that doesn't work because after 5 you get 4, and then this is not okay. So which is why when I say 6 choose 3, there are 2 cases like where 2, 3, and 4, or 6, 7, 8, and then any other cases does work. You can confirm if you are not satisfied. So of these, there is 2 selection that doesn't work. So that's 6 choose 3, which is 20. 20 minus 2 is 18. So that means 18 ways to finish this as well. But the case 3 is actually the same as the case 1, because when you have this is 4, right? We have this 12 ways. When you have this is 6, you will actually end up getting the same thing. And then if you are not really convinced, you can just do what I did and then just choose 2 numbers and then go from there. But you have 12 ways from this as well. So if you add those, you get 42 ways to finish this arrangement. So the number like 42 as answer is not too like large number. This is just 3 by 3 grid. But if this was like 4 by 4, maybe even 5 by 5, the things will be a bit challenging. So for those kind of stuff, the casework still might work, but it's going to be too tedious. So if you are interested, there is another way of doing this problem, which is called hook length formula. So I'll ask you to take a look and see if you can get that approach as well. But that would be interesting approach as well. Okay, I'll see you in the next video.